my name is Atrisha Zuana binti Turiman. So this is my video for final year project. Let's start with problem statement. There is a problem with brick production as excessive cement consumption such as sulfur dioxide, nitrogen oxide and carbon monoxide has a negative influence on the environment. In other cases, a large amount of leftover solid waste such as bark and hampers is generated, which is generally burned or washed into adjacent streams, which have resulted in pollution and health risks. As an alternative, this study is being carried out to evaluate the availability of SFW as a replacement for cement in brick, hence decreasing pollution. The first objective of this study is to determine the compression strength, density, and initial rate absorption of cement bricks containing Sago fine waste as partially replacement for cements in accordance with standard of bricks. And the second objective is to obtain optimum percentage Sago fine waste used in bricks as partial replacement materials for cement. Next, proceed to the scope of study. Fieldwork and laboratory work are involved during completing this study. The size of block mold that been used for manufacturing the bricks were created according to the scale from Malaysian standard and British standard. There are 72 total bricks that were going for testing in this study. The mixed ratio of cement and sand is 1:3 with water-cement ratio fixed at 0.6, and the water curing process must be done for 7 days and 28 days. In this investigation, ordinary Portland cement, OPC, sand, water and Sago fine waste, SFW, are the materials that had been used for the production of cement bricks. Let's start with Sago fine waste. The Sago fine waste that used for this study was obtained from supply of a Sago mill in Muka, Sarawak. The figure shows the SFW that has been processed. The replacement volume of SFW that has been selected to replace the cement is 0%, 1%, 3%, 5%, 7% and 9%. Next material that had been used in this study is ordinary Portland cement, OPC, which was obtained locally at laboratory of UTHM. Natural white sand, also the material that had been used in the study, which also obtained locally at UTHM laboratory. The last important material in manufacturing the cement bricks is water that used as a binder for sand and other materials improves the performance of cement. Let's move to the three material testing before proceed to the further laboratory testing. The first is sieve analysis to produce fine aggregates that meet the particle size for both sand and SFW. The result shows the SFW have the potential replacement in cement bricks since the fine modulus for SFW and fine aggregates are almost similar. The second testing material is specific gravity. The result shows the specific gravity of sand is higher than SFW. The third is the video shows the process of bulk density testing. Now let's move to the process how the brick was prepared as shown in the figure and video, where the mixture been prepared by hand mixing. After the mixing process is done, the mixtures will then be used to cast a total of 72 bricks, and the sample must then be left for 24 hours before being removed from the mold. After that, the brick samples were involved in wet and dry curing process for about 7 and 28 days. Now, let's proceed to the three laboratory testings, which are density, compressive strength, and IRA tests. First is density test that must be carried out accordance with British standards and formula given. The density result shows when the percentage of SFW replacement is increased, so the density value is decreased compared to control, which it will produce lightweight brick that have numerous advantages. Next, the video shows the process how the compressive strength test was conducted in this study. This test is used to determine the durability of bricks used in building construction and was carried out in accordance with British standard and formula given. The result of compressive strength test showed the value of strength decreased due to the increasing percentage of SFW content in cement bricks. However, the samples of SFW1 still obtain the highest compressive strength compared to the other samples and still meet the requirement of standard. Last testing in this study is initial rate of absorption as the process shown in the figure. The formula given is used for this study. So the result of IRA value obtained still meet the requirement from the standard, where the graph result shows that all samples bricks do not exceed the values of 2. For the conclusion, it can be concluded that the density, strength, and IRA performance for cement bricks are significantly impacted by the replacement of cement with partial SFW. It can be proved when percentage SFW increase, the both density and strength of cement bricks are decreased while the value of IRA is increased when compared to the controlled bricks. At the end of this study, the best optimum percentage SFW was selected, which is the sample of SFW1W0.6. This sample SFW1 has the highest value of strength, which is 15.13 MPa, and this can be used for load-bearing internal wall for constructed of small single-story housing as well as commercial and industrial buildings, while the other samples still can be used for partition wall but do not carry the loads. In addition, this best optimum sample also has the normal weight brick and the lowest IRA value. However, all the results obtained from this study are still meet the requirement of standards for bricks. Lastly, in terms of environmental impact, there might be significant values in reduction of Sago waste in the river stream and reduction of carbon emission from cement, because the SFW can still be used for mixing of manufactured bricks. That's all from me. Thank you for watching.